Okay, so what we have done is we connect the LCD like this way, right? So we take outputs from pin 8. Yeah. So we take the output from pin 8, right? So we connect to a LED. Right. Then the other side of these LED we connect to ground. Right? Yeah. So the pin 8 last week we defined as output, right? So basically the microcontroller gives output to this pin, right? So then this pin is connected to a LED, right? So you see LED is blinking, right? That's what we have done last week. Is right? So basically, this pin we define as an output pin, right? Output pin, right? Because the microcontroller basically gives the voltage to this pin. Okay, and we also discuss the input, right? So what can be the input? Basically, the input have to come from the external, right? From a user, for example, right? So now I put a button here, right? I'm not sure whether you can see it. So I have a button. So this is a button, right? You can press, right? You can press and release, right? So through this button, actually you can give the input to the microcontroller. Basically, you can design your program such that, let's say I press this button, right? I want to light up LED. I release this button. I want to turn off the LED. Right? You can do a program like this one. So I'm going to show you today, right? So basically, you can take the input from the push button. Okay. So the push button basically is your input. Right? So this push button I'm going to connect to a pin 6, right? Then pin 6 will become my input pin, right? So I have a push button here. I have a push button here. Right? Push button here, right? So push button basically has 2 pins, right? So one again is connect to a ground, right? The other one I need to connect to pin 6, right? Pin 6, right? So again, this pin 6 will be my input pin, right? So whenever I press this push button, right, the microcontroller will receive the input, right? So this input last week we also discussed, right? We have this pull-up resistor, right? Connect to this input pin, right? So basically, what it means is, if you don't have any inputs, right, this input pin is always high because there is a pull-up resistor, right, connect to VDD. You still remember this one, right? So for this input, basically we define as an input pull-up, right? Input pull-up. Right. So this one indicates there is a pull-up resistor, right? So if you don't have any inputs, right, the input is always high, right? So we don't have any undefined state for this case, right? Yeah. Okay. So I'm going to show you this part, right?
Cheese stick.
Okay, so this is the ID you have seen last week, right? So again, let me get a magnifier to choose more. Okay. So that's why the program, right, we can take the input from the physics, right? So again, to start, right, we need to define some variables, right? So last week we say integer LED, right, equals 8, right?
Isn't this the research?
Okay, so this one basically is the same as last week, right? So we define the LED pin as number 8. You can choose
Yeah, serious ah. That's stupid lah.
Then
You
this
have
week
this,
we
then you still need the
introduce one more
this assessment already.
pin, which is for the push button, right? Push button. So this one we choose number 6. Again, you can choose number 6, 5 or 3.
Who say once
So
who say once the paper?
So in the
Cannot
in the
access this.
setup function, right? Basically, this is the configuration, right? We want the program only run once, right? Okay. So here, what we define last week, we define the pin mode, right? You remember? Pin mode. So LED as
Oh, still don't need to do this one. Don't need to do this one.
Okay.
You attach this
So
there,
this is
unless you
also what we
sign
have
this
done last
scan
week, right? So again, a few things I want to mention again, right? It's case sensitive, right? So that means if you don't use correct case, right? Capital or small letter, right? The color won't change. Okay. In mode again, right? M is capital letter, right? Okay. Now so this one we say we want to define as an input. It's an input pull up. You can define as an input. If I put the input, right, the color also will be the correct color. Right? But what it says we want to define as an input pull up. Okay? And also in the setup, right, we want to make sure if you don't when this microcontroller, right, don't receive any input, you want to turn off the LED. So for this program, we want to design this way, right? So say I want to digital write the LED thing, right? So this is my initial condition, right? Will be low, right? Okay. So that means at the beginning, right, LED is off. Okay. Digital write also you see last week, right? It's the function. Right? It's the function coming from the this IDE. Alright, so this is the setup portion. Okay, let's move to the loop function. Right? So loop, basically last week we say the loop part basically is the part of code, right? Will continuous running. Right? Okay, so for this one. So now we need to check the inputs, right? So if, right? So if else, you know, basically this is we are going to discuss again, but if basically you can make the selection. So if my input is, so just now we discussed, right? For input pull up, if I don't press the button, my input is high. Okay. Only when I push the button, my input becomes low. Right? That means if I push the button, actually the input is low. Okay, that's input pull up. That means if my digital, I need to use the digital read function here, right? So I need to read this thing, which is the button thing, right? Okay. So if this one is low, right, that means I push the button, right? Yeah, we need to think about it. Okay, so I need to put all of my if codes within this bracket, right? So if I push this button, I want to turn on, right? Turn on my LED. So I need to digital write to my LED pin as light. Okay. It's okay. So that's high, right? And so far, do you understand what's going on here? Yeah. Okay. Basically, what I have done is I use this digital. I use this function, which is called digital read, right, to read the value from this pin, right, which is the button pin, right. So if the input is low, right, that means I have to press the button. So now I want to turn on my LED, right? So I need digital write to this LED pin high, so that the LED is turn on, right? Okay. So then I can introduce again some delay function, right? You can see the LED is turned on, right? Then I want to turn off this one. There are many ways to write this program, right? Basically, I want to show you one here. Okay, so I want to turn off. Okay, so this program is done. So I want to connect to my Arduino. Okay, so this program is done, right? I want to send it to the Arduino board, right? So you need to check whether the board is correct. So I want to send it to the board. So you can see the okay.
How they say gonna need to send to the supervisor? They never say, right?
But just email your
Okay.
friend.
So just
By this
now,
Friday lah.
okay, just now
And the introduction all this
I again make a mistake here in the case, right? Just now I put LED as a capital letter, which is wrong.
跟唱也是啊。
I need to use a small letter to be consistent.
Just that this one is a separate copy.
So you see, if I use a wrong case, right? Just now I received an error in compiling. So I need to send it again. Yeah, so now it's okay. so now I want to show you the result here. So now, this program is already transferred, right? So now this program is already transferred to the Arduino board here, right? Okay, so now you see the LED, right, is off, right? So if I press here, so I need to connect the input to pin 6, right? Pin 6 is here, and pin 8 is here. So if I press, okay, let me change one LED. I think this one is because of the loose wire. Let me check again. Okay, it works. Yeah. So just now the wire actually is loose, not because of the LED. Okay. Okay. So this is you are going to try also in the lab, right? Okay. So now you see, right, the microcontroller now actually takes my inputs, right? I press the button, right? So the Arduino actually receives my input, right? That's my input, right? I tell the microcontroller I want to turn on the LED, right? So I press it, right? The Arduino receives the input and turn on the LED. If I release, right, that means I want to turn off the LED, right? So the LED turn off, right? Okay? So actually there are many ways to write this kind of program, right? The program just now I show you, right, it's not the only way. Okay? So different students actually can come up with different if else, whatever, right? Different controls. This one actually is up to the designers or the engineers. Right? So now basically I have already shown you, right? So now the Arduino, right, can get the inputs, right, and also it can produce the outputs, right? So you have the idea, right? Okay. Okay, so now let me go through the Arduino your board, right? So you have seen some of it already. Yeah? So we mentioned the core part of the Arduino board, right? Actually is this microprocessor chip, which is called SAM3X, right? Which is what's that? The microcontroller core, right? So this is the key chip, right, in the board. So how to use this chip SAM3X? Actually, there are many ways you can use it. Okay, so the chip itself actually only costs $5 to $8, right? Then you can actually design a PCB board. To design a PCB, your own PCB board to use this chip, right? But the initial cost actually is pretty high. right? Because you need to spend quite a lot of time, right, to come up with the design, how to use this chip, right? Okay. And what are the minimum components you need for this kind of system? Minimum you need power supply, right? And also you need some components to provide the inputs, right? For example, like this button, push button you already see, right? You can also use switches or different sensors to produce the input, right? So you can actually buy some sensors, for example, like temperature sensor or motion sensor, whatever, right? So the sensor actually produce some outputs, right? Your temperature or your movement, right? Then you can connect these outputs to the microcontroller, right, as the input. Okay? So these are the inputs. Or you can interface to other components, right? You can interface to other microcontrollers or processors. And you need to also have outputs, right? So the components which can produce outputs from the microcontroller can be LEDs, right? LEDs or the sound buzzers, right? You can actually produce some sound, right? Speakers, whatever, right? Or it can be data logger, right? And you can save your data to a SD card, whatever, right? Or it can interface to other components. Okay, right? So for any microcontroller system, right? These are the three minimum components: power supply, input, and output. This actually is one of the exam question last year. It's a short question. Okay. And any additional components you can have? You can have a reset button, right? So what is the reset button do? Basically, you can reset. Okay, so you see, just now, right, when I send my program to this Arduino board, right? So actually my program is saved in one of the memory chip here. Okay? And if you have a reset button, actually you can press the reset button and erase this program, right? You can reset your Arduino board to the original state, right? So actually there is a reset button on this board, okay? You can reset the whole thing, okay? So, and what are the additional features? And the programming interface, right? Yeah, this one you see actually from you have the IDE, right? What we call is the integrated design environment. So this one it will make the life a lot easier for you, right? Because you can do a program in the IDE and you send your program to the board, right? And also it will be a lot easier if you have the external crystal. This one will provide the precise timing for your microcontroller system. Okay. And for the microcontroller development system, right? You need to have a computer communication interface, right? You can connect your board, right, to the computer, right? Okay, and you will have hardware debuggers, right? So whenever you write a program, right, you need to have some capability to debug it, right? Because for any program, right, it's impossible you can make it right at the first time, right? You have to debug, right? You have to try, right? And of course you need to have a programming environment, right? So for example, the IDE just now you see, right? And also for the simulation environment for our Arduino case is not necessary. You know why do we need a simulation? Simulation most of the time you need it because let's say your hardware is very expensive. You cannot afford to try many times, right? Because if your hardware is very expensive, right? So you have to make it right at the first time. So basically, you want to do a simulation first to make sure the whole design works right before you port it to the hardware. right? But for our Arduino case, because Arduino is so cheap, right? You can always write a program and send it to Arduino, right? You try it out. If it doesn't work, you come back to your program again. You change something and send it again, right? Yeah. So for this case, you don't need to do simulation. Yeah. Okay. Because the hardware is so convenient, right? You can always write something and send it to hardware to test, right? But for some of the designs, you cannot do that. Do those things. For example, like IC design. I'm not sure whether you learned IC design before. Because whenever you do an IC design, right, you need to do a thorough simulation check because you know your hardware, right, IC, you need to send it to the external fabs to fabricate, right? So the process is very costly, right? It can easily like $500,000 or so. Right? So the whole process is very costly. So for IC design, you have to do simulations. Right? You need to make sure your design is completely functional before you send it for fabrication. But for our Arduino case, right, yeah, you don't need to do that. Right? Okay, so it depends. So for this, again, this is one of the exam questions last week also. It's a short question. It will ask you what is the microcontroller development systems. So that gives you an idea, right, what kind of question you are expecting from the exam. Okay. So let's come back to the how to use this the chip, right? So you can design your own board, and most of the time, right, you can get the evaluation kit from Atmel. Right? So this evaluation kit basically it will include the chip here, and also it gives you other components so that you can interface to the external hardware, right? So you can see the list of the components, buttons, LEDs, SD card interface, etc. So this is the evaluation kit from the manufacturer itself. Or you can use Arduino Duo. Okay? You can use the Arduino Duo. So, you know, you see, Arduino Duo, right, actually can do almost the same thing as the evaluation kit, right? But why the Arduino Duo is so popular? So actually, I want to share with you a little bit of the Arduino, how this Arduino is come out, right? So you know, Arduino, right, the founder itself, it's like 10 years ago, he was asked to design something come up with something for designers to use. You know, these designers, right, they don't have electronic backgrounds. Right? They are for example, like they are the game designer, they are computer programmers. So he was asked to come up with something that the designer can use to design their interactive game. So he was at the beginning, right? He feel it's very difficult, right? Because you know the designers, right? They don't know anything about electronics, right? So you have to come up with something, right, which is very easy to use, right? And the users don't need to know much about the electronics, right? So this is what Arduino come about, you see. So the idea Arduino actually it hide a lot of these electronics details from the users. So the users don't need to have an electronic background, but they still can play with the Arduino. So that's why you see these days, right? Even the secondary school kids, right? They can write programs for this Arduino, and they come up with some useful applications. Okay, and the Arduino becomes so popular, right? Because it's easy to use, yeah? Very easy to use, and also the other reason actually because of its open source. Right? Once it becomes open source, right, you have a lot of resources you can find in the web. Right? So these actually these are the two reasons why Arduino are so popular these days. Okay. So yeah, so this one we have gone through, right? Arduino basically is a single board microcontroller. It's a one board, one piece of board, right? Okay, and with the complementary components, right, that facilitate programming and incorporate into other circuits. So they are the open source hardware board, right? What it means is they are the open source hardware, right? So hardware itself is open source. Basically, that means you can manufacture this board, right, without any IP issues, right? Okay. So this means open source hardware. So you can see these days, right? A lot of these China manufacturers, right? They also produce the Arduino board because the hardware itself, right, is open source, right? It's free. Okay. And the key component where we have discussed basically is the hardware, this microcontroller, right? So 8-bit or 32 bits, right? So the most of the Arduino actually use 8-bit processors. For example, like Arduino Uno, right? Maybe some of you used before. Arduino Uno actually is using the 8-bit processors. And Arduino Duo, we are going to use in the lab, right? Actually use the 32-bit processors. Okay. And the other one is a very interesting feature is the Arduino has a set of these shields, right? How these shields can be used actually, because all the connectors, right, they are the standard external connectors. So if you buy the Arduino shields, right, basically you can stack on top of each other, right? Let me show you the picture. For example, this one. Yeah? So you can stack up many shields, right? So different shields basically they provide different functions, right? So the basic Arduino board, for example, they don't have the function for Wi-Fi, right? So for example, like the Arduino Duo, the board don't have they don't support Wi-Fi, right? But you can buy a separate Wi-Fi shield, right? And you plug on top, right? You can actually connect to Wi-Fi, okay? And the other one is, for example, like Bluetooth or Internet, all these functions, right? All these functions actually the basic board don't provide. But you can always buy an external, you can buy an additional the shield board, right? In order to connect to the Bluetooth or Internet. Okay. So that's why the Arduino becomes so powerful. Right? You can add a lot of functions by adding the shields. Right? So actually last time I saw one picture, right? They stack up about 100 shields. Right? Okay. And the other one is very convenient. Is you have the standard cross-platform IDE. Right? So this is the design environment, the software you saw just now. Okay. Okay. So for Arduino, actually you have many boards, right? Yeah. You have either this. Actually, the most popular one is the Arduino Uno. It's a small board, which is the first Arduino board. So you have this Arduino Nano, which is a very small, and Arduino Duo is here. Right? Some of you mentioned Arduino Mega, right? Also, this is one of the popular boards. Okay. And Arduino Shield, basically, we have discussed. Basically, you can expand you can have a lot of these expansion boards, right? To increase your functionality. You can have Wi-Fi, Bluetooth, Ethernet, XP, touchscreen, etc. Okay, so if you want to have more information, you can go to this Arduino official website to get. So you can get the free libraries and different boards information, etc. So let's say if you want to use it for your FYP, so this is a good website you can use to. So Arduino Duo, so you have seen it before. So This one basically is the power supply. This is the SAM 3X chip we have discussed. And you can see there are two ports here actually. One is called programming port, the other is called what we call native USB port. So we use this programming port to send a program to this board. And this is the erase button we discussed earlier, right? So once you press this button, basically the program you send it to this board is being erased. So this board will revert back to the original state. Right? And we also discussed. You can see the ports here, right? These are basically the digital I/O. These two rows are also digital I/O ports, right? And here are the analog I/O ports, right? So we have about 50. Yeah, this one you can check the exact number. About 50 digital I/Os you can use. Just now in the example we use pin 6, pin 8, right? Yeah. So it's somewhere here. Of course, you can use, for example, pin 20, pin 30, right? They are also available. Okay.